Hi everyone, let's look at a Leetcode problem today. It's called non-overlapping intervals. Given an array of intervals where intervals I equals start I and I, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Two keywords, minimum and non-overlapping. Let's look at the first example. 1, 2, 2, 3, 3, 4, and 1, 3. We can see that 2, 3, and 1, 3 are overlapping. So we can remove 1, 3. And after removing it, our intervals are 1, 2, 2, 3, and 3, 4. They're not overlapping. So our answer is 1, which is the number of removed intervals. The second example, 1, 2, 1, 2, 1, 2. All of them are the same, so all of them are overlapping. We can remove 2 of them, and we return 2 in this case. The third example, 1, 2, and 2, 3. They are not overlapping, so we just output 0 in this case. So how to solve the problem? Let's first take a look at an example. 6, 7, 5, 9, and 8, 15. We can see clearly that some of the intervals are overlapping, such as 6, 7, and 5, 9. So we have to remove one of them and keep the other. But which one to keep? My strategy is to keep the one with the smaller end. In this case, I will keep 6, 7 and remove 5, 9. But why? Because the problem demands that the number of removed intervals be minimum, which means the fewer overlappings the better. If we keep the interval with the smaller ends and remove the other, that kept interval will have a lower probability to overlap the next one. In our example, if we keep 5, 9 and remove 6, 7, 5, 9 will overlap 8, 15, then we should remove another interval again. So in this case, our result is 2 because we removed 2 intervals in the whole process. But if we keep 6, 7 and remove 5, 9, 6, 7 won't overlap 8, 15. So the result will be 1 in this case because we only removed 1 interval in the whole process. As you can see, choosing 6, 7, which has a smaller end than 5, 9, would be a better choice. Its answer is smaller. If you still don't understand, I will draw these intervals for you and go through the process step by step. Okay, let's first draw 5, 9, and 6, 7, and 8, 15. Okay, as you can see, we should keep 6, 7 because it has a smaller end. If we keep 5, 9, it will overlap with the next interval 8, 15. And when that happens, we need to remove one more interval again. Our results will be larger in this case, which contradicts the problem's description. It requires a minimal result, so keeping 6, 7 would be a better choice. It won't overlap 8, 15, and we can get a smaller answer. So we figured out which interval to keep when overlapping happens, which is we should keep the interval with a smaller end. The next question would be how to find overlapping intervals. One obvious strategy would be to check adjacent intervals one by one. Take our previous intervals as an example. If we have 5, 9, we have 6, 7, and we have 8, 15. We check the first 2 intervals first, and then we find that they're overlapping. We should keep 6, 7 and remove 5, 9 because 6, 7 has a smaller end. Then we check 6, 7 and 8, 15 and we find that they're not overlapping. So our answer will be 1, which happens to be correct. Notice that I said it happened to be correct. It only happened to be correct because our strategy won't work for all the cases. It only works for our case because our intervals happen to have the optimal order. I can give you another example where that strategy doesn't work. The example is 1, 2, 2, 3, 3, 4, and 1, 3. Okay, let's follow our previous strategy. We compare each pair of adjacent intervals 1, 2, and 2, 3, no overlapping. 2, 3, and 3, 4, no overlapping. 3, 4, and 1, 3, no overlapping. So our answer would be 0 because we removed 0 intervals. Is that correct? No, of course not. You can see that 2, 3 and 1, 3 are overlapping. So what's the problem here? The problem is that we didn't sort our intervals. We should sort our intervals by their ends. The intuition is that by using this method, we put overlapping intervals next to each other so that we can find them just by comparing adjacent intervals. Just like this, we should put this behind and we get this and this. As you can see, we have already sorted the intervals by their ends. The ends are 2, 3, 3, 4, and they are sorted. Then we compare these intervals one by one. First, we compare 1, 2, and 1, 3. They are overlapping, so we just remove one of them. We removed one with the bigger ends, which is 1, 3. Then we compare 1, 2 with 2, 3. They're not overlapping, so we keep them both. Then we compare 2, 3 and 3, 4. They're not overlapping either, so we keep them both. So our answer in this case will be 1 because we only removed one interval, which is correct. So, in conclusion, the process of solving the problem is first, sort the intervals by their ends, and second, we should compare each pair of adjacent intervals. And if they're overlapping, only keep the one with the smaller end. That is how you should solve the problem. Okay, let's code. Let's first sort the intervals by their ends. Then we're going to define two variables called first index and the second index. They represent the indices of the intervals we're comparing. We need to check if the two intervals are overlapping. So the initial values of the two variables are 0 and 1 respectively, which represent the first and the second interval. And we also need to define the return value which is going to be returned in the end. Since we're going to repeatedly compare adjacent intervals, we need a while loop. And the while loop continues while second index is less than intervals length. And inside the while loop, we need to check if the two intervals are overlapping. If they're overlapping, like for example, 5, 7, 4, 9, and 10, 15. Suppose first index is 0 and the second index is 1. And you can see that the two pointers point to the first two intervals, 5, 7 and 4, 9. And they're overlapping. In this case, we need to remove the second interval 4, 9 because it has a bigger end. Notice that it's also possible that the second interval's end is equal to the first one, like 5, 7, 4, 7, and 10, 15. In this case, you can remove either of them, and we can still choose to remove the second interval. So, in conclusion, we only need to remove the second interval when overlapping happens. Okay? Because we're going to remove the second interval, we first increase the result by 1. Because it stores the number of removed intervals. The second interval will be one of them. Then because the second interval is removed, we increase second index by 1. So that second index will point to the next interval. And in our example, the second interval will be changed from 4, 9 to 10, 15. And we will compare 5, 7 and 10, 15 in the next iteration. And if there is no overlapping, such as 5, 6, and 8, 10. In this case, suppose first index points to 5, 7, second index points to 8, 10, and we have another interval 12, 15. Since 5, 7, and 8, 10 are not overlapping, we will compare the next pair of intervals in the next iteration, which are 8, 10, and 12, 15. That means we need to assign the current second index to first index. And we also need to increase second index by 1, so that we can continue to compare the next two intervals in the next iteration. And that's the basic structure. To complete the code, we need to implement is overlapping, which is pretty easy. We just return intervals 1, 1 is greater than interval 2, 0. And when that happens, we think that the two intervals are overlapping. So this is the complete code.